Good evening, pre-calc. So today, this lecture, we're going to be talking about drawing angles in standard position. And that's actually going to be our objective as well. Objective is drawing angles in standard position. Standard position. Now, a secondary goal during this lecture is to get you guys a little bit more familiar in talking about radians. Now remember, radians are just a unit of measure, just like feet, miles, kilometer, ounces, temperature like Fahrenheit, except in this one it's just the unit of measure is for degrees, right? So it's measuring an angle. So just like in degrees, if you start with something really, really narrow and then you open it up, right, the angle is getting larger and larger and larger. Same thing with radians. It's just a different unit of measuring degrees. So before we get into talking about standard position, there's a few key things when talking about sketching angles. Now, standard position, the reason we use standard position is because whether you're drawing angles, I'm drawing angles, somebody in China is drawing angles, somebody in outer space is drawing angles, we need some sort of standard way of doing it so that people can understand from one angle to the other exactly what you're talking about. So there's a few key things that need to be done in order to draw angles in standard position. The one is to use a standard XY axis. Or a standard XY coordinate plane. I'm going to go ahead and start off just by drawing one of those here. So here's our standard XY coordinate plane. Now the distance on the coordinates don't matter so much when you're doing angles, but typically because most angles are used to describe the unit circle, usually you start off like one unit, right? So it's just 1 unit by 1 unit by 1 unit by 1 unit in every direction. The second thing you need to know is that you're always starting off on the x-axis in the positive direction. So you're always starting on the positive x-axis. Now, this is, of course, different than the negative x-axis would be at this point over here, or the positive y or the negative y. So you're always going to start from here. So the initial angle measurement is always this line right here, from 0 to right there. Right, so that's going to be one sort of the rays that makes up your angle, is that positive x-axis. The third thing you need to know is that if you're looking for an angle that is positive, so I'm just going to say plus theta. So theta is a Greek letter that's usually reserved for talking about angles. And so plus theta just means a positive theta. You're going to be going counterclockwise. And if you're talking about a negative theta, you're going to be going clockwise. And CCW and CW, counterclockwise and clockwise respectively, those are standard abbreviations for counterclockwise and clockwise. And of course, these just come if you're thinking about sort of the hands on a clock. So you've got the long hand, the short hand, and numbers 1, 6, 3, 9, etc. Oops, that would be 12. 12, 6, 3, 9. The hands on the clock go this direction, so this would be clockwise. The hands on the clock going this way would be totally backwards. That would be counterclockwise, the opposite direction. Okay, so we're going to start off in, there's different ways to draw angles in standard position. And there's different techniques to be able to do it. I am going to push you guys to try to think about angles in terms of radians. And so you can convert them to degrees if that makes it easier for you guys to understand. But really I want you guys to focus on radians because that's a common unit that's used in angles and it's going to help you solve problems later on. And so one of the most common angle measures right here, and there's 4 of them that I want you guys pretty much to have memorized. So this one right here, you just go 1/4 of a turn. This angle measure is just pi over 2 radians, pi over 2 rad. Now, of course, this comes from if we take an entire path or an entire revolution around and end up back at the same point, then we're going to have 2 pi radians. And so if we just go a quarter of a turn, then we're just going to end up doing pi over 2 radians. Now there's 3 other ones that I want you guys to have memorized. Okay, so that's pi over 2. The other ones, really, if you just know 1 or 2 of these, you can derive what the other ones are. And so the other one is if you go a full half spin around, right? So this is going to be our pi over 2 position. This is going to be our pi position. So this angle measure right here, from once again starting at this position and going in this direction, this angle measure right here is just pi radians. Now the other 2 may start getting a little bit obvious for you guys. Once again, if we start here, and here we're just going to go 3/4 of the way around, whereas this one is pi, this one's pi over 2, so same thing, if we go pi over 2, pi, we're going to stop over here. This angle measure is going to end up being 3 pi over 2 rad. And the last one that I want you guys to have memorized is 1 full revolution. And really this is probably the best one to start off at, because 1 full revolution you should know is 360 degrees, or hopefully it's burned into your brains by now that 1 full revolution is also just 2 pi radians. Now, how do we draw angles in standard position? There's a lot of different ways to do it. The first way is probably to try to get an idea of where the angle, what coordinate plane the angle is in, or what quadrant the angle is in. Now if we look at sort of a standard coordinate plane, then the quadrants that I'm going to have, you guys probably know this already, hopefully this is review, is quadrant 1 is going to be sort of the positive x, y. Then we just sort of label them coming around here. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so for example, if our angle goes off in this direction, then it's going to end up in quadrant 1. Oops, let me go ahead and move this. It's going to end up in quadrant 1. If it goes off in this direction, then it's going to be quadrant 2, down here 3, and over there 4. Okay? So just having a rough idea of what quadrant your angles are going to end up in is going to help you sketch them. And so in this example, I'm going to say, go ahead and sketch this in standard space, just pi over 4. Now, if I think about the ones that I've got memorized up here, I know that this is 0 degrees right here, or 0 radians right here. I know that this is pi over 2 radians right here. Well, pi over 4 is smaller than pi over 2, right? So if I have half a pi, if I go half a pi, that's going to be bigger than if I have a quarter of a pi, right? So I'm not going to go end up in quadrant 2, I'm going to end up in quadrant 1 somewhere. So if I'm trying to sketch this thing, I can actually notice that pi over 4 is exactly halfway between 0 and pi over 2, right? So if I take pi over 2 and I divide it by 2, or if I multiply it by 1/2, I'm just going to end up with pi over 4. So I can notice right there that, hey, this arc, this angle that's formed right here, this is going to be our pi over 4. And we could also say that this ends up in the first quadrant. So I could say quadrant 1. Excellent. Now it's going to get a little bit more tricky. Okay. The next example that I have, let me redraw here. Next example I have for us is, okay, now instead of pi over 4, what if I'm looking at, say my theta is equal to 5 pi over 4. Theta is equal to 5 pi over 4. This gets a little bit trickier. So the thing to remember here is if you want to sort of remove the pi from it and just think about 5 over 4. Okay, so instead of just, I know 1 revolution is 2 pi and half a revolution is 1 pi. So if I can think about it just in terms of the numbers, I can say, okay, so halfway around is just 1 and 1 full revolution is going to be 2. So this 5 over 4, I'm going to break this down. I know that 5 over 4 is greater than 1, but it's less than 2. Okay, so already I know that this angle is going to go greater than 1, but I'm going to stop it there because I don't know exactly how far it's going to go. So I'm going to rewrite this in terms of pi. So I know I'm going at least a pi, so I'm going to pull a pi out. So in order to do this, I'm just basically going to break this up, and I'm just going to say this is 4 pi divided by 4 plus pi divided by 4. And so the reason I did this is I realized that, okay, so the same denominator, pi plus pi, or 4 pi plus pi over here just gives me the 5. And the denominator is the same, so that's just going to be 4. And then 4 pi divided by 4, 4 over 4, that just becomes 1, so I'm talking about pi. plus pi divided by 4. Same thing, I'm just rewriting my 5 pi over 4, so it's just a different way of thinking about it. When you guys get good, you'll be able to do this really quickly in your head. So I've got 5 pi over 4 is equal to pi plus pi over 4. Well, I just sort of plotted what pi over 4 was right here. And so this is 1 pi, that's half a revolution around this quadrant. And then I need to know, I know that I need to go pi over 4 more, which is going to end me up right about there. So now I know that this angle right here is 5 pi over 4. I'm going to put in parentheses there. Knowing that, hey, this section right here, let me go ahead and get some markers here. So that this section right here, this pink section, is 1 pi, or just pi. And this orange section right here is going to be pi over 4. And so the pink and the orange together make 5 pi over 4. So that's exactly what I would do. And if I look at my quadrants, sure enough, I'm in 1, 2, 3, I end up in the third quadrant, or quadrant 3. Now one more example before I leave you guys this time around. This time I want us to look at a negative angle. So we've always been going in the counterclockwise direction, the positive angle. The last example I've got for us is, what if my theta is going to be equal to negative 3 pi divided by 4? Negative 3 pi divided by 4. So once again, starting off with my standard coordinate plane, x, y, and I'm always going to start off at that point right there. So I know my first line for my angle, my first ray, is going to be right there. And so if I look at this, negative 3 pi over 4. Well, 3/4, I'm just going to focus on the fraction here. 3/4 is greater than 1/2, right? So I know if I'm going in this opposite direction, the same thing is going to happen. So I'm going to end up going, okay, so this is going to be negative pi over 2. This is going to be negative pi, negative 3 pi over 2, and finally back over to negative 2 pi. So just because it's a negative doesn't mean that these intervals, as 90 degrees is equal to pi over 2, is going to change at all. So what's going to happen is, I know that this is greater than pi over 2, but it's less than pi. Greater than pi over 2, but less than pi. So I know I'm going to come up to here to negative pi over 2, right? That's what this is, negative pi over 2. But I'm going to stop before I get over here. And if I rewrite this just like I did before, and I pull out that negative pi over 2, so I'm going to rewrite it like this initially, negative 2 pi divided by 4, plus, oops, it would be a plus a negative, plus negative pi divided by 4. So if I do this math real quick, 2 pi plus pi is just going to be 3 pi, and the denominator is the same thing. So this negative 2 pi divided by 4, I can reduce that. So that just becomes negative pi divided by 2 minus pi divided by 4. So as I'm moving around my circle here, I know if I start here and I go negative pi over 2, that's it right there. That takes care of this guy right there. Now I know I need to go just a little bit further, and this is going to be my negative 3 pi over 4. So this is negative pi over 2, that's that guy. And this little section right here, this is negative pi over 4, that's that guy. So this whole thing right here, going in the negative direction, is negative 3 pi divided by 4. I'm going to leave you guys there. I'll try to put up another video with some extra examples if needed.